Okay, welcome back to our optimization class. So from one moment, last week we we discussed about multi-period, right? Multi-period problem and multi-period optimization problem and assignment problem. So today we move to the next type of problem. This kind of problem, we call it knapsack problem. Wow. Do you know knapsack? No? No?
No.
Okay. All right. Let's say that, well, you have a backpack. So your backpack is has certain capacity, right? You can carry well certain amount or certain weight, and it has certain volume also. It can carry just certain volume. So if you use that knapsack or no that backpack, you carry that backpack, and you enter a shop, and I ask you, well, freely, you can take anything freely as much as you want. However, you have to pack everything in your backpack. Okay, so you have limitation, right? And then you have to design what to take. Okay, similar situation. While this problem, a company wishes to ship a number of crates from Toronto to Kitchener in a freight container. The crates are of 6 possible types. We have 6 possible types. And each type of crate has a given weight and has a particular retail value. Okay. So each type of crate has different value, also different weight. So we have this table. This table gives you information regarding each type of crates. For example, for type 1, the weight for type 1, the first type of crate, is 30 kilogram. Okay. And the value is just $60. Okay. For one single crate. Okay. For type 2, of course, it has different characteristic. Weight is 20 kilograms and the value is 70. Okay. We also have different characteristics for type 3, type 4, type 5, and type 6. Okay. So what is the problem? Well, we move from the constraint to the objective first. Then we go back to the constraint. The total weight allowed on the freight container is 1,000 kilogram. Okay. And your goal is to design how many crates of each type to place in the freight container. Okay. So that the value of the crates in the container is maximized. Okay. We would like to maximize the value. Okay. And we have certain set of constraints. Okay. Now back to the constraint. We have the following constraint. The first one, you cannot send more than 10 crates of the same type in the container. Imagine that. Well, for the container, you cannot have first type, type 1, 11, 12. You cannot have that type more than 10, okay? Each time more than 10. And what else? You can only send crates of type 3, if you send at least one crate of type 4, what does it mean? If you want to send, if you want to choose type 3, it is a must that you must also choose type 4, at least one crate. Okay? And the next constraint is at least one of the following two conditions has to be satisfied. Okay? Either one, this one or this one. Okay? A total of at least 4 crates of type 1 or type 2 is selected. Okay? Or a total of at least 4 crates of type 4 or type 5 or type 6 is selected. Okay? So we need 4 crates of type 2 or type 1 or type 2. Or we need 4 crates of type 5 or type 6. Okay? Either of these conditions will satisfy this constraint. Okay? So what is our objective? Back to our objective function. Maximize what? The value, right? The total value. Okay? So based on this information, right? Because, well, the value of each type, the values of each type are given in this table already. Okay? So we have to write the objective function as a function of decision variable. So we have to design our decision variables. Think about it. What do you think is a good set of a decision variables?
Number of crates.
Number of crates, right? The number of crates for each type, right? We need what the number of crates for type 1, the number of crates for type 2 until type 6, right? That is fundamental, right? But we want more, one more condition, decision variables to represent whether this condition is satisfied or not. Because in the third constraint, we have two conditions to satisfy. The first one is a total of at least 4 crates of type 1 or type 2, right? Or a total of at least 4 crates of type 5 or type 6. We don't know yet whether this one should be at optimum condition, this one should be satisfied, or this one should be satisfied. But either of them, it's okay. So we use y, okay? The one decision variable, y, which is a logical variable to handle the constraint satisfaction, okay? Okay, we have decision variables combined of encompass x1 to x6, right? And we have another logical variable, y, to handle the constraint satisfaction. Now we move to the objective function. It's quite straightforward because our objective function is value, right? The total value. And we're going to maximize it. So while the x1 is the number of crates for type 1, so the value of the type 1 is 60 times with x1, right? It's straightforward. And we have 70 x2, 40 x3, 70 x4, 20 x5, and 90 x6. Good. Now we move to constraint. For the constraint, the total weight of the crates must be, yes, less than 1,000. So you check the total weight first. The total weight is 30x1 plus 20x2 plus 30x3 plus 90x4 plus 30x5 plus 70x6. How do we get, well, this information from the table, right? From this table. Back to this table, okay? Because this table gives the information regarding the weight of each type. And the second constraint is, what is the second constraint? We cannot send more than 10 crates of each type, right? So xi must be lesser or equal 10, okay? x1 less than or equal 10, x2 less than or equal 10 until x6 lesser or equal 10. And for x3, this one is interesting. This is already, wow, the next constraint already. We move to the next constraint, the third constraint, was it? Oh, no, the second constraint, yeah. You can only send crates of type 3 if you send at least one crate of type 4. We can express that idea as, well, this one. X3 must be lesser or equal 10 of X4. What does this mean? X3 can be positive if and only if X4 is greater than 0. Okay? If you don't send X4 type 4, that means X4 is 0. And in that case, you cannot send X3, right? The constraint, our constraint forces us to do that. Okay? So we write X3 is less than 10 of X4. Okay? If we send X4, if X4 is greater than 0, X3 can be positive. Okay?
Sir, is there
Yes.
is there a reason that it must be 10x4?
Well, think about, well, if you write X3 is less than X4, you see that if X4 is 1, what happened to X3?
It also can be 1.
X3 can be only 1 or 0 or 1, right? But in our constraint, if X4 is 1, X3 can be anything less than 10, right?
Okay, sir, I get it. Okay.
Okay. Okay, then we move to the next one. The next one is, well, we consider the third constraint. X1 plus X2 must be greater than or equal 4y. Or X5 plus X6 must be greater or equal 4 times with 1 minus y. What does it mean? Remember that y is the logical variable handle the condition of our constraint, the third constraint, right? So y can be only its logical variable. It can be 0 or 1, right? Okay. And if y is 1, what does it mean? if y is 1, x1 plus x2 must be greater than 4. Okay? So we have this constraint to force the total, no, not the total, the number of creds of x1 and x2 must be greater than 4. Okay? And we leave the constraint on the x5 and x6. Okay? When we relax this constraint. However, if otherwise, if y is 0, if our y is 0, what does it mean? We relax the first constraint, right? x1 plus x2 can be anything greater than 0. We don't have that constraint. However, we post the constraint on the fourth line. x5 plus x6 must be greater than 4 times with 1, right? So on the right hand side become 4. Okay? This right hand side become 4. Okay? So if y is 1, what does it mean? If y is 1, this constraint, a total of at least 4 creds of type 1 or type 2 is selected. Must be true. Okay? However, if y is 0, the second one, a total of at least 4 creds of type 5 and or type 6 is selected. This condition is true. Okay? And the most important constraint, all the xi must be 0 or positive. Also, why? Why? Because y is a logical variable, and it must be logical variable. It can take 0 or 1. Okay? It can be 0 or 1, just that. So we formulate the whole optimization problem as following. We maximize the objective function. Our objective function is 60x1 plus 70x2 plus 40x3 plus 70x4 plus 20x5 and plus 90x6. Yes. Hmm? This one, right? This constraint, right? Okay, you need explanation. Okay, we this constraint, right? x3 less than 10x4. What is your question? Your question is on 10 or the whole line. Why we need 10 here? Okay. Well, consider the case where we send x4. Consider the case where we don't have 10 here. What happened? If we don't have 10 here, we write x3 is lesser or equal x4. Then once x4 is 1, what happened to x3? x3 cannot be greater than 1. However, our constraint is we can send any number of x3, but we need x4 to be 1, right? At least 1, not x4 to be 1. That means, well, if x4 is 1, we can send even 10 x3. Okay? So you need 10 here, right? To conserve the meaning of the constraint. If you don't have 10 here, that means, well, we cannot send x3 more than x4, which is not true. Okay. Yeah, this is xi must be positive. Okay. And y must be binary. Yeah, I think well we are ready to solve this problem. Okay. Try to formulate it in MATLAB or in Excel, whatever you want. But the problem of Excel is you need solver. You need a special solver because Excel cannot handle. Linear programming cannot handle logical variable. Okay. However, because we have only one variable here, logical variable here, if you want to use Excel, you can force y to be 0 and solve the problem. And then again, you force y to be 1 and then solve the problem and see which one show yield higher objective function, and then well that is your solution. Okay. Online also, well, work with us. Please use MATLAB or Excel to solve this problem. Okay, so well, this is my code to solve that problem. We start from YAML clear and clear all. Okay, as always. And then we define our decision variable. X is invar. Okay, integer variable from, well, contain 6 variables. And we have Y, which is binary variable. Okay, this is 1 because it's scalar. And we define the vector of the weight and set the solver. Then we have constraint for the following constraint. What do we have? Each x must be positive, but less than 10. Okay. In YAML, you can write this way. X is, well, between 0 and 10. Because x is vector, so YAML will treat each element of that vector must be greater or equal to 0 or less than 10. Okay. And we add new constraint. X3 must be lesser or equal 10 of x4. Okay. Oh, sorry, I did not ask you, but you can use YAML, right? You can install YAML and MATLAB. No. Hmm? Yes, and install Gurobi also. Okay, good. Why? Okay. Yeah, I will check. And we add the next constraint. X1 plus X2 must be greater or equal 4y. And X5 plus X6 must be greater or equal 4 times with 1 minus y. And the total number of weight, the total weight must be lesser or equal 1,000. Okay. Then we move to the objective function. For the objective function, we use, because YAML, we treat all the objective function as a minimization. So if you want maximization, it's very easy. Just the negative of your objective function, right? So, well, instead of profit, we take negative profit. So we minimize negative profit. So it becomes maximized. I think, well, in my previous video, not previous video, the video I filmed 2 or 3 years ago, I show you how to install YAML and Gurobi in Macintosh, in Apple, in MacBook. You saw it? Yes, but everything is in Thai. Yes, because that class is in Thai. Hmm? Uh-huh. Okay. Okay, we saw it first, and then maybe, well, we take a couple of minutes to review how to install MATLAB and YAML. we solve the problem first. Okay. Yeah, I love to see this successfully solved. Okay. And then you want what we want? We want value of x, right? The solution is x1 must be 10, x2 must be 10. Then we have 0, 0, 0. And the last one, 7. Okay. With the objective function, obj fun, maybe. No, not obj fun, obj. Yes, it's 1930.
Sir,
Yes.
for the x, right? Why did we use 1 6 and not 6 1?
I can get your point. Why is it?
Oh, the x equals to int var. Yeah, why don't we
Yes.
use 6 1 like last time? Like why
You can use 6 1. It's the same. I can show you.
Good.
Okay. Now we change to x 6 1. Okay. Then we solve. Oh, sorry. Sorry. Must be 6 1. You can change to must be 1 6. It's okay to change to 6 1, but I will show you here. Yeah, it will be a problem here.
Why?
If you write 6 1, your W must be 6 1 also. You get my point? W,
Yeah,
now we declare W as 1 6. Okay.
I see.
Okay.
Oh.
If you use 6 1 here, oh sorry, yes. Yeah, at 6 1 here, W you have to use no this sorry, this 30, right? And 20, 30, 90, 30, 70. Yeah. Your W must be in this form. Okay. Also the P also, right? Because later we have to times the P with X. Okay. So the because dot star means each element, right? But well, your W, the dimension of your W and X must be identical. Also, dimension of your P and X must be identical.
I see. So last time did we do 1 6 or 6 1 kind of?
I cannot remember, but this one, right? Which one?
Yeah. Oh, yeah, this one.
This one is for 4.
Oh, I
Yeah.
see. Oh, so that's why. Okay.
Okay. For KW, we use 4 1.
Oh, 4 1.
Yes.
But why does this one work? So.
Oh, this one is okay because well, you see that our objective function here. We declare objective function this way, and the price no, we declare the objective function this way, right? Now you see that well, we can times 4 1 with this one, right? Because
but
we don't use dot star, we use star. What is the dimension for price? You see,
it's 1 4 for price.
it's 1 4, right? Correct. I don't know why. Okay, just one moment. This is 1 4, right? 1
Yes.
4. So you can time 1 4 with 4 1, right? And it becomes 1 1.
Yes.
Okay.
I see.
So mathematically correct.
Oh.
Okay. If we define the t as 1/4 and price as 1/4. This way we have to use the objective function must be price dot star p. Okay, and then we sum up all the element together.
So we can do like
You can do
anyway.
either way. You can do either way. Yeah.
Okay. Okay, sir. Oh, sir. Hello.
Is everything okay? Any questions?
Sir, I
Yes,
have a
yes, yes.
question. For
Yes, please.
the constraint, the line number 9.
The line number 9, yes, this
Yeah,
one.
yeah. Why don't we use the for loop, like for 1 to 6 and then xi?
You can do either way. Yeah.
Oh, okay.
You can write, wow, line by line, like this way. X1, sorry, 10, yeah, you can write this way. Yes, and also X2, X3.
I see.
But this, but what I show here is much easier, right?
Mm.
Yes.
Okay.
If X is vector, you can write this way. And
Okay.
Yao Ming understand, okay, and interpret correctly.
Oh, okay, sir.
Okay, good. So, well, we have a, well, 10 minutes maybe. So, well, you install, do you have any problem regarding the installation of the MATLAB? Yes, you can install it. No, you cannot. Okay, so what's the problem? Show me your MATLAB. You download MATLAB, right? Okay, yes. Click. Yes. And it becomes, well, a drive. Yes, because that is a virtual drive. Okay. Yeah, wait until. Oh, one more thing. I almost forget. Well, the exam will take 80%. Okay, midterm it's 40%. 40% for midterm and final another 40%. Okay, and 20% for other activity. Okay.
Hello, sir.
Yes.
Hello.
Yes. Yes. I can
Sir,
hear you. Yeah.
please, can I get insight into the nature of the exam?
I can. Wow, I can
Please,
hear you,
can I
but it's not
get
clear.
insight into the nature of the exam?
Can you type in the chat because your voice is noisy.
Okay, can you hear me now?
Yes, better. You type in the chat, okay?
Yes, I'm typing it.
Okay. Yes, click that one. Double click. I think you should download the latest version. Yeah, download. Yes, this version. I don't know what version I'm using now. This 2023A. The same. So
I'm finding it difficult to send it via chat.
pardon?
I'm
Pardon?
finding it difficult to send it via chat.
Why? Why you cannot type on the chat?
Yes, it's not sending.
Chat in Zoom, right? YAML and yeah, test it. Enter. Yes, enter. Okay. Yes, you have YAML, but you don't have solver. Oh, just one moment. Maybe you have it. Yes, you have Gurobi, right? Yes, you can. This problem can be solved by using Gurobi then. No, this is maximum. It will be difficult to see. You run it first. Okay then. Okay, good. So run it. Run. That. One moment. This is star dot. No. The problem is this line 13, right? Sum of star. Oh, sorry. Star dot you have. No, 1 6, not 6 1. 1 6. 6. Okay, run. Save and run again. Save, yes, and run again. Yes. Okay, you can solve this problem. Yeah. The problem is you see that not only logical variable here. We also need integer variable, right? Because x is a number of creds, and we cannot have half of a cred. Okay, we need integer. You need spatial solver. ได้ไหม
Sir,
Yes.
are you there? Could you try and run the 6.1 version or not? Because
6.1.
yeah, because when I try it, I don't get the answer. Like when it is 6.1, and then I remove the the dot, and then I don't get the answer.
One moment.
Hmm.
6.1 here. And
Yes.
6.1. Then we have what we have. This one, right? So what do we need? This one we have to comment out this one, and for this one, just one moment. Oh, 6.1 time with 6.1. No, must be no. Which one is? Oh, sorry. This is 1/6. Yes, time with 6.1. Yes, it should be okay, right? This sum.
Yes.
And the other thing is here, objective function should be
remove the dot. Yeah.
Yes, we remove the dot. Okay. See first if it is okay. If we can run it. Yes. It's solved.
Could you try and
Value?
print the value? Yeah.
Yes.
Okay, something
same-
must be wrong
same
with my
result,
code.
right?
Okay, sir.
Yes, the same result.
Okay. I don't quite get why I'm wrong. Okay, I'll go and try and solve it.
Okay, I will send this file to the group. Okay.
Okay.
I will post it in Line group. Then or later. Okay. Now it's not convenient for me.
Okay, sir.
Okay. So any more question? Actually, you can use AMPL or of course, if you want to use Gurobi. I'm not sure Gurobi provide the in Python or not. Gurobi Python and Gurobi in Python for yes, Gurobi optimization come with a Python extension module or Gurobi Py. That means if you are more convenient with Python, you can use Python and use Gurobi. Okay, but of course I cannot help you much on that because I'm not familiar with Python. Yeah, but you can read. You can go through the Gurobi website and check if how to use Python. Or the other possible way is AMPL. This one. What's A? Oh no, AMPL. Sorry. Yes, this is AMPL. It's another modeling language. Yeah, which is similar to YAML, but the good thing is for AMPL, you don't need MATLAB. You can write in the structure of AMPL, right? Again, I cannot consult. You cannot consult me for AMPL. I don't know that syntax. But what I use is MATLAB and YAML. Okay. And do we? Oh, sorry. Okay. For those on Zoom cannot see what I'm working now. Yes, we're talking about AMPL, right? This AMPL modeling language and Python. You can use Python with Gurobi. And the good things about AMPL is similar to YAML. It can interface with other solver also. You can model your problem in AMPL and then interface with Cplex, interface with IPOP and other solver also. Okay, any solver available, you can try yourself. But of course, you have to study how to model using AMPL. Okay, and Gurobi, I think I'm not sure whether it's available for in solver. In Excel. So yeah, the problem is Gurobi does not provide an Excel add-in. Okay. Sorry about that. If you want to use Gurobi, you cannot use Excel. Okay, good. The question is, can I use optimization toolbox instead of YAML and Gurobi? Yes, you can use optimization toolbox of MATLAB, but the problem of optimization toolbox is once you change the solver, you change the command. I mean, you have to, because each solver requires different parameters and also the syntax is different. So you have to study the command of each solver. Okay. Even the optimization toolbox of the MATLAB. If you decided to use those toolbox, you have to study. You have to consult the document and you have to, well, learn the command. Okay. But you know that YAML can interface with MATLAB optimization toolbox. I can show you. Yeah. If you look at my screen, YAML test, I will show you that you see that for linear programming. No, it's for linear programming. YAML interface with Gurobi. Quadratic programming also use Gurobi, and second order cone programming also use Gurobi. Semi-definite programming we use Sejumi, yeah, which is different solver. And you see that for geometric programming, nonlinear programming, nonlinear SDP is semi-definite programming, and even exponential cone programming, YAML interface in my computer. YAML interface with fmincon, and fmincon is the optimization toolbox in MATLAB. Okay. Okay. So what I want to tell you, I want to tell you that if you want to use fmincon directly without YAML, of course you can go ahead. You can work with that. However, you must study how to interface with fmincon. You need different parameter and command, right? However, if you use YAML interface with fmincon, the solver of MATLAB, and you don't have to do anything. You just select the solver, just that. Okay. You model the problem the same way. Okay. You don't have to learn a new syntax. Okay, good. So, well, we finished for today. Any questions from Zoom?
Yes, I have a question.
Yes.
So I figured out what I did wrong. So we cannot switch the like W times X and X times W. Like we cannot
we cannot, because, well, you know, A times B, it's different from B times A, right? For metric.
Yes, but how do we know like which one is which?
You know, well, for metric, let's say, yeah, I show you. Just one moment. I cannot write on this, so what shall we do? I can use Keynote. Just one moment. I can write in Keynote. No, not right. Just typing. Okay, you see my screen, right?
Yes, I see your screen.
Okay, so if we have A star B, you see the A star B, right?
Yes.
Okay, so what is the dimension of A? Oh, wow, sorry. This is okay. So what is the dimension of A and B? For example, we have A, which is M by N. M by N, okay? Times with B must be N by anything, maybe L, okay? Matrix. Think that A is matrix, B is matrix. You can multiply A and B as long as the number of what? Number of column, right? Row and column, right? Number of column of the first element, of the first parameter, first variable, must be equal to the number of row, right? So
Yes.
the result becomes C must be M by L, right? Okay, so well, if we have W, which is 1 by 6 times with X, which is 6 by 1, right?
Yes.
Your result will be 1 by 1, right? Which is scalar, because it's 1 by 1 already. However, if you write X 6 by 1 times with W, which is 1 by 6, your result becomes 6 by 6. Yes. Okay, it becomes metric. 6 by 6.
Okay, sir.
Okay. Okay, I can delete, right?
Yes.
Yeah.
You can do it.
Okay, so have a good day. But yeah, and we see again tomorrow at 4 o'clock, and then well, the next week, for this week, we see again on tomorrow. But tomorrow is Tuesday, right? Tomorrow is Tuesday. Yes, we have class tomorrow. And for Friday, we don't have class, but I will record video for you. 1 more hour. Okay, another example. 4 o'clock. Okay. And for next week, maybe 3 times a week, too many for you, right? So we can see, well, 2 times a week and 1.5. 1 hour and a half. Yeah, each day will be good. Okay, because 3 hours, I think it's too much because, yeah, for evening. But 1 hour may be too short. So yeah, 1.5 will be better. Maybe next week we will see on Tuesday and Friday. Yeah, 1.5 will be better. Okay. Yes. Question? First example. Yes. What is your question? Run and then? Is not correct or what? Okay. I will give my code for first problem, right? You on the line group, right? Okay. I will upload that to the group. Okay, good day for you all. And well, we should see again. We should meet tomorrow, 4 o'clock. Okay, use the same link. Okay, use the same link for Zoom. I noticed the problem already because I select repeat every 4 weeks, 3 weeks. Yes, but we will repeat every week. Okay. Okay, thank you. So, well, later I will upload the video and also I will send you the M file.